All right, Thunder. Bring it on, I guess. Also, you really butchered the spelling of physics there. The more I look at that. Okay. Live on YouTube too. Hopefully the Discord images are working today. But yeah, just feel free to send it. Hey, Steely. Physics. You're right, Thunder, my bad. Nothing much with me. How's it going for you? Is it Steely or Stelly? I guess it's spelled more like Stelly. I feel like I've asked you this before, so my apologies if you've already told me. Yeah, sure. Thunder did ask a question first, but if Thunder's questions are usually pretty involved, so if you want to just go ahead and put your question out there, and I'll see which one is quicker, I guess. Yeah, sure. Three watch streak. Ooh, thank you. You probably feel free to still send your question, Thunder, so I can like start to look at it. In the meantime, I'm just waiting to see the questions. Let me give these like PDFs to around the pages that I was on. I don't know if I'm gonna do that much studying today, but I don't know, I just have these PDFs like ready. Oh, what's that? X? So this is solving it for X? It's okay. Stelly, I'll write down what I think you're saying on the board here, and you tell me if I'm formatting it right. How far did those X's go? Oh wait, these are minus signs. And then I think in the denominator, these were both inside it, right? Okay. And so you're solving this for X? It's weird. So this absolute value is it's very weird. Yeah, Thunder, agree. It's find X? Okay, yeah. So whenever you have an absolute value, you have to consider two cases. One where the absolute value of X minus 2 is like the positive version, I'll say, even though X could be anything. Or one where X minus 2, oops, has a negative sign in front. Because both of these will lead to the same result with an absolute value. But the thing is, if we have this case on the right, I think we can immediately throw this out. Because in the denominator we have X minus 2, minus x minus 2. And that's just always 0 no matter what. Because x minus x is 0, negative 2 minus negative 2 is also 0. So we don't get any solutions ever from the negative version of this. Oh! Zach, thank you so much for the raid. Oh shoot, what did I just hit? I just hit a weird hockey. Oh, I know what hockey I hit. Never mind, it's fine. Felix, hey. I hope your data collection was good, Zach. Even though my conspiracy theory is still that you were just having fun with Scrabble. Smiling Inside Ice, thank you for the follow. I said hi to Felix. Hey, Jed. Hey, Pause DX, thanks for the follow before. Hey, Waffle. Data collection by the air quotes, yeah. Hey, Smiler. Felix. Oh, shoot, and I should say hi to Viv, too, who's here just before the raid. I still think you should get a bachelor's commission from Caltech. Then you should change it to some math. You're right, Viv. That's a good idea. Yes, Stelly, I will. Sorry, I just want to get caught up with chat here. You're next on my list of distractor and mastering for Scrabble. I'm terrible at Scrabble, though. Noble Penny this year? Oh, okay. You were overdue for a name change, so. This real name Don does quote unquote math. That's true, Jed. Yeah, math is the cover up. Okay. Felix, I can take a better look at that. I'm still working on this question from Stelly, and then there's a question from Thunder as well. 2424 Vixa, thanks for the follow. Let me just read it quickly, because maybe if I just can't do it, then I can tell you that now. Number A0. You have a number A0, now you use A0 times the rule. What does F has to be that it satisfies? Oh. I'm not optimistic for being able to do that question, Felix. It seems like there's some kind of interesting thing there, but I'd have to think about it a lot more. So I might try it after I can like do this question and then Hunter's question, but okay, sounds good, Felix. Yeah, I'm not optimistic that I'd be able to help you out with that question. It does look interesting though. Okay, so yeah, still sorry for the pause there, but and for anyone who's just joining, Stelly gave this question of this equation and we're solving it for x, and in doing the absolute value, I first looked at like the negative version of this and saw that we never get a solution because we're dividing by 0 for every value of x. So I think we only have to worry about the positive case here. And the problem really becomes over x minus 2 plus, now x minus 2 with no absolute value because we're only considering the positive version. And I'm saying positive, but you could get a negative number from this because x is a variable, but I hope you know what I mean with that. So let's combine terms on the bottom. X minus 3, x minus 4. And we get what, 2x. Actually, there's a simpler way to write this. We have 2x minus 2s, so let's say 2 times x minus 2. And I'm writing like this because we're going to get a cancellation here and here. But that also means if we do cancel this, we throw out any situation where x is equal to 2. But that's fine. So if I do this cancellation, the x minus 2s go away. And we have just a 2 on the bottom. We just look at chat. If I was to throw no x less than 0. Yeah, I think x less than 2 I've thrown out. Yeah, I was wondering how to express that, Jed, and I think you're right. That by throwing it, or by, you know, looking at this case, we know x is never going to be less than 2. I don't know. Is that a symbol like not less than 2? That seems kind of stupid, but regardless. Oh. That might actually come into play here. So now what would happen is this over 2 is just a constant coefficient. We can break this out into 4 different problems. We can take x equals 0. We can take x minus 1 equals 0. We can take x minus 3 equals 0. And we can take x minus 4 equals 0. So immediately there's one potential solution which we need to check with x equals 0. We have a potential solution with x equals 1, x equals 3, and x equals 4. And I'm saying that these are potential solutions because there's weird stuff happening with what x is allowed to be when this absolute value is involved. So I want to go back in and plug things into the original equation to make sure that these are actually solutions or not. I know there's a better way to just like know immediately whether these are solutions or not than plugging in and checking, but plugging these in manually isn't that bad. I don't think so. Let's try plugging in 0. So we get, and the top isn't that important, but 0 times -1 times -2 times -3 times -4. The bottom's what we're more concerned about because we don't want to divide by 0 accidentally. So we get 0 minus 2 plus the absolute value of 0 minus 2. Oh, and see, we are going to get issues here when x equals 0. Because we get -2 plus the absolute value of -2, which is +2. So on top, I'm just going to write a 0 because 0 times anything is 0. And on the bottom, we get -2 plus +2. We get 0 over 0. So this thing is not defined for x equals 0. X equals 0 looks like a solution, but it's not a real solution to the original equation that we asked. It's a solution to this other equation we got by doing some simplifications, but it's not what the question was. Yeah, so Felix found the idea. That's what I was thinking would happen because we know x has to be greater than or equal to 2 from this part on the right here. I wasn't that confident. That's why I'm saying that we should go back and check it. And if you're like me and not all that confident in this type of math, I'd recommend that you do the same because that's just the way that you know that you're right versus just thinking right, I guess. So I'll try the same thing with 1. Just to show that it shouldn't be a solution either. On top, we're going to get a 1 minus 1 is 0, so I'm just going to write the numerator as 0 and not do all that writing like I was before, because we're really concerned with the bottom here. 1 minus 2 plus the absolute value of 1 minus 2, right? So we get 0 over -1 plus the absolute value of -1, so we do get 0 over 0 again. So yeah, 1 is not a solution. And just to show it with 3, we will get a 0 on top again, but 3 and 4 are going to be different because we get 3 minus 2 plus the absolute value of 3 minus 2. That's +1. That's also +1. So now they're not canceling. We get 0 over 2, and that's just 0, which is great. That's exactly what we want. We want this thing to be equal to 0. So you'll get the same kind of result if you try it with 4 as well. How do you know that x has to be greater than or equal to 2? It's because from this bit on the right here, we know that a negative result from the absolute value is bad. You're always going to be dividing by 0. And this thing is a negative number when x is less than 2. Because yeah, I guess it's hard to. I'm not doing a good job of explaining it, but like, this thing is a negative number if you have something that's less than 2 for x, and that's kind of the scenario that this thing on the right dealt with. I just dealt with it at first by sticking a negative sign in front, but that only really happens when x is less than 2. So, all right, sounds good, Stelly. And Vixa, I hope that explanation just then helped, but let me know. Right. Oh, yeah, Thunder, you're actually right. You're not actually right. You are right. Yeah, I was being a little bit messy. Like, we can write just greater than 2 there. We know x isn't going to be exactly 2 because if x is exactly 2, then we're dividing by 0. So we can be a little bit more correct and take off the or equals. A big check mark? Oh. The graph looks like a check. Yeah, that makes sense. Let's see. Here we go. It is a big check mark. Yeah, it cuts off at x equals 2 as well, which is expected. So let's take a look at Thunder. You just can't comprehend the last question. Okay. Ugh. Sorry, I'm saying ugh because whenever I download a PDF now, it automatically opens in Adobe Reader, and it's kind of annoying. Like I don't want it to do that, but oh well. Oh, yeah, I could do that. I mean, sometimes I do want to open it in Adobe Reader, I guess, but it's just like whenever I download any PDF through Chrome, it just like opens it automatically in Adobe Reader, and I don't get why. So you're saying you can't comprehend the last question, which is right here. Scale in grams is marked on the spoon. What? Okay, well, I need to read the setup, I guess. Yeah, I can't comprehend it either, for what it's worth so far, Thunder. Let me open up the answer thing you sent me to, just to have it. A spoon used to measure the mass of food. Button next to open with. Am I able to rotate it on my end? Not in the 2 seconds I took to look at it. I mean, I sometimes do want to look at it. I mean, I guess I could always like manually open it with Reader. I do see that property that you're talking about though, Jed. I don't know. It's fine, Thunder. No worries, Stelly. Just finished your exams for the year. Awesome, anniversary of parts. Congrats. Thanks for like letting me know that. So it's good to hear the feedback, I guess. Tilts. Okay, so x is the distance from the midpoint to wherever the balancing point is now. Okay, I opened a random, like I don't want to show my Chrome on stream because it's like my personal browser, but it's also like my system's default browser, so usually things get downloaded through it. I open a random PDF in my Chrome and I right-clicked on it. I don't see anything that's that like relevant. Oh. I see. You meant you're talking about the rotating now. There's image accessibility properties. I wonder if that. Oh. I can inspect it. Can I do that same transform thing? It's really not that important. Who cares? I just gotta look at the question. I'll just tilt my head. I don't care. So resource for understanding topics. No, we're in different time zones. Oh, nice. Are you able to catch another streamer's like I guess streams more often out of curiosity, or is in like one of the time zones just like hard to watch stuff in? So I've had some people saying that it's like I hold on with a question and then they'll say it's like 5 in the morning for them. It's like, oh geez. Control bracket. That doesn't do anything. You weren't available for teachers. ChatGPT is really good. Oh, fair enough. You're in Europe. Europe time zones math streams are dry. Yeah, definitely in the morning for Europe. I can see it being dry. The person who streams the earliest I'm aware of is Phobos. Yeah, I think SPQ is somewhere. SPQ streams like later in the day though. I don't know. Yeah, it's just rough. I mean, probably my biggest thing is like trying to grow the math niche on Twitch. So hopefully it'll actually the problem will solve itself. Most is most often when you see it. Okay. Post something in math help. Okay. Oh. That is going to be a rough one. Let me keep looking at Thunder Sky. I'll take a better look at it, but I'd like to figure out what's up with this one. Total length is 32 centimeters. Weight of the food x through a line. We already have the answer key integration by parts, so I know I think we'll be okay with this. I was just trying to understand what the last question is asking, I think is what Thunder needs to know. Like how to interpret the wording of the last question. How the uncertainty in the value read from the scale changes as m increases. Hey, you hear some serious haters? So they're using this graph to calibrate the scale, and I assume that means you're putting a known mass m into the scale and measuring what the distance should be. That's how they're doing this. How does the uncertainty, like, would it be more uncertain the smaller the weight is? Because measuring the difference between like 0.01 of a gram and 0.001 of a gram is a lot harder than like 5 grams and 50 grams or something. Scale from P to the edge of the bowl. Oh, that's weird integration by parts. They make you just like count the squares. This might be one where I need to read the answer and then reverse engineer what they were asking. Yeah. All right, tilt your heads. Oh wait, check this out. I know exactly what I can do, at least for the stream. What degree rotation is this? Is it 270, I'm gonna guess? What? Where did it go? No, no, I wanted a 90-degree rotation. Now, this is only on the stream's point of view. There we go. Perfect. Also, I can't make it go, wait. Okay. I still have to tilt my head, though. Maybe I should tilt my head and then tilt the webcam back so it looks normal. That's almost it could be, at least. Absolute uncertainty in m increases as m increases? Oh, that's not what I was saying before then. That's the opposite. I thought the uncertainty would be more for smaller m. Because as m increases, marks on the scale get closer. How do you know that? Or range of values of m for a fixed range of x increases. Should I have read the question closer? Check the additional part. And P1 is only worded. Okay, so figure 11 is obviously important here. Let's go back. I think we need to look at like this is the important bit. Oh, because it has this increase. At 25 grams, the distance between the lines 1.5 and 175. I'm saying the uncertainty increases because here you have nearly 3 whole or like a little bit more than 3 whole centimeters for 50 grams of weight. And their point is that like over on the right side here, you only have like a bit, like about a centimeter for 50 grams of weight. So you're compressing the same amount of weight into a smaller area, and it's harder to visually tell the difference between like a small difference in grams. I think that's what they want you to notice here. They're saying absolute uncertainty in M increases as M increases. Well, was there a part where they said that it decreases? Increases? Okay, okay. Yeah, it's just about like the if you'll get in like 50-gram increments, you have like more resolution or you have more fine-tuning ability the bigger the distance is, because you just have like more room to slide it back and forth. So like for this first 50 grams, you get 3 centimeters of wiggle room. For the next 50, you get like 2. The lines get closer together. Yeah, Thunder. Like, imagine like what would happen as you physically move this spoon back and forth. And the higher the weight is, the smaller the change, like, or rather the bigger a difference each change makes. Like, it's really hard to fine tune it for a heavy weight. But for something that's like between 0 and 50 grams, it's really easy to like slide it back and forth and find the sweet spot. Whereas like, I guess like the sweet spot for like something that's 200 grams is pretty small. But for something that's 25 grams is pretty big. For however the scale's set up, I guess. One last mini question? Okay. Yeah, this seems like some kind of like piecewise thing, integration by parts. It didn't seem like one clean function to me, at least. Ooh. What's happening here? Refractometer. Oh, hey! I know what these things are, kinda. Explain why the light ray in figure 12 does not change direction as it enters the block. So why doesn't it change direction over here? Wait, it changes direction up here at the liquid. but they're asking about as it enters the block, which is like this point down here. And I assume they made this a circle so that it specifically doesn't change the angle of light going through. Is incident on the midpoint of the horizontal surface. I mean, does the shape of it really matter though? I think that's just glass. I assume they're going to say something about like this ray of light being perfectly like perpendicular to the like the edge of the circle there. I don't get why if this thing was a square, anything would be different though, to be honest. Because I don't really know how light works. But rays incident along / at the normal out? What? That's not a word. OWTTE? Am I watching Zach play Scrabble? And all these things that don't seem like words are apparently words? Refraction would occur if it was... Really? Okay. A-level physics isn't real. I mean... I guess if you did have a square, you would have to go perfectly... No, that's weird. I don't know, that's still weird. I mean, I can believe this. I just don't know anything about how light actually works. Like, I couldn't explain physically why that happens, but I can just guess from the graph that they're giving that that ray of light being perpendicular to the tangent is the important bit. You get that? Oh! What? Let me show that on stream. Because that also looks cool. Like, this would be a good, like, desktop background. I couldn't tell you why, but I don't know. Light's weird, I guess. We should get rid of light. What has light ever done for us? Oh, I have no clue in enrichment parts. Snell's law? Angles of incidence and refraction. Snell-Descartes law. Ooh. I don't know what I'm doing either, to be honest. This seems like refraction, I guess. 2 brain cells already overcooked. Okay, so I think that's the bottom of Thunder's question. I should look at your other questions, Stelly. In Felix, maybe actually. No, I feel like I'm not gonna be able to get Felix's question. I was more quick looking at the absolute value sign on the bottom. All right, so still, this is a pretty crazy thing to have to simplify here. Let me bring it up. Oh, okay. That's something, Felix. How would this work? Like, the cube roots make everything so much harder here. Yeah, the real answer here is calculator. Oh, Thunder, yeah, I see the image you sent me as well. That still doesn't... I guess the angle of the medium? Okay. I don't know. But I guess... Oh, well, oh god, integration parts. Please tell me the trick. Assuming it's not Wolfram. What am... No, I don't know the trick here. Hey, Nikas. Oh god. The real trick here is Wolfram Alpha. Stelly, are you just quizzing me here, or do you actually need help with this? You actually... Okay. I just want to make sure, because if you're just asking me for fun, then I'm just going to plug it into a calculator, or let Wolfram Alpha tell me what the trick is. Yeah, I'm wondering about, like, I mean, the sum of the difference of two cubes doesn't really help here, but... Can you somehow get this into a plus b cubed, each of these? Because with cube-roots, it doesn't seem like... Just factor out the power of 1/3? No, you can't do that. I do have a ceiling fan. Are you able to hear it? So I've seen problems that like give you a super weird looking square root, and you can prove that the number inside there is a perfect square and simplify it. And this might just be a harder version of that problem. Or maybe you can see the reflection of the ceiling fan on the whiteboard? Oh, you definitely can, yeah. Go to the first term. Perfect square way also works. Okay. So it's the cube root 20 plus 14 root 2. Plus, oh god, I couldn't decide if I wanted to write the 2 in the 20 or the 3 in the cube root. So, oh wait, or is there's something else that we can do here? You got 4, wow. Calculate the value of the expression. No. This is I just got a big old bottle of the whiteboard cleaner. Because I had like one of those like tiny bottles, but I actually went through it kind of quick, so. like, so one thing I've seen, if you have like just one of these, is you would take 20 plus 14 root 2 is equal to like some a plus b cubed and figure out what a and b are, which isn't that easy either, but we do have the two cube roots that are nearly the same with the difference of just a sign, so I wonder if you do something else with it. Hey Jaden, it's an easy question, not for me. Cube both sides? I was wondering about cubing both sides, but like... Don't do too much of it? Okay, Nikas. Yeah, Jaden, feel free to put a solution in if you want. You need to cube? All right, let's see what happens, I guess. Sounds kind of painful. Well, if we cube each side, we definitely get I should do this carefully, I guess. Because I'm gonna mess something up. And then if I just take that and square it and put it over here, and then I'll multiply this one in after, like... yeah, that's fine. You can do it in my Discord too, if that's easier. But if you'd rather do Imgur, then it's like that works too. Plus 2 times those two things multiplied. 196 times 2. What is 196 times 2? 400 minus 8, right? Which is 392. Oh, hey, that simplifies. I don't feel like writing that out again. Actually, you know what? I'm just going to multiply this in right here. So we're going to take this, multiply it in here, here, and here. That's to the 1/3, that's the 2/3. So you get just 20 plus 14 root 2. This times that. That's 400 minus 392 is 8, so the cube root of 8 is 2, so this is really 4. Plus 4 times cube root it's 14 root 2. Then that times that. They have different bases. I don't know how that's going to work. Hopefully it just cancels out, I guess. And we multiply this into all three of these. Root 2 to the 1/3. What's up, Thunder? Sent it on. Oh yeah, I mean. I see it now. I mean, I'm not opposed to doing it my way. I don't think it was gonna. Well, I assume we get a cancellation. We might actually get a cancellation. It might be kind of painful. Let's see what Jaden is saying. Oh, so it's just like a similar problem. What? That's not what you get from cubing each side, though. Or you're skipping over a bunch of steps. It's a Y? Oh, okay. Hey, Phobos. Oh, I appreciate you. Okay, so, I mean, that's valid if you just want to not deal with everything else and call it Y. But then how do we deal with the Y? Oh, no, this isn't shorter. This is the same exact thing. And it's a little bit cleaner, I guess, but like 3ab times a plus b. Yeah, you factor out a 3a and b from this thing in the middle. Okay, so that's where that comes from. That's a... Wow, wait. Where does the n come from? Oh. Oh, that is the n. It's the original thing. Oh. So like my work is technically the same. It will be much harder to notice from my work that we get this a plus b term back. Oh, interesting, Henbox. I'm probably not gonna. I know I don't really like Epic personally, but basic math in your notebook. 4 hours thoughts. I don't know. I don't know how it works, Viv. I wouldn't mind it. All right, so yes, you asked earlier if I can do it Jaden's way, and I definitely can. That's the way that I was doing is not wrong, and I'm actually going to continue from the work that I was doing. Well, no, maybe I won't continue from the work that I was doing. The idea that it rests on, if you have any two generic numbers, a plus b, and you cube it, you get a cubed plus, oh my god, I'm too lazy to do this myself. Let me see what Wolfram. 3a squared b, 3ab squared. Oh, I mean, I could have just binomial theorem with that, I guess, but who cares? Plus b squared. And we'll take the a cubed and the b cubed up front because we have these cube roots, and we're going to get a nice cancellation with the cube and the cube root. But these two other terms we have to deal with. So we can factor to 3ab from each of these. And the neat trick here is that was a plus b cubed. There's an a plus b here. Maybe this is bad notation because we're using a here also to mean a different thing, but basically we're going to be able to do a neat sub with this relationship here, the a plus b, like repeating itself. UWV count after e to 2i pyrade. I do need Pascal's triangle, yeah. 65,000 times higher, Viv. You're kind of a genius. I like the way you think. Okay, yes, let me just tear down this work. So I'm just gonna, a is this thing, I'm just gonna cube a, and like over here, that's the a, that's the b in this scenario here. 20 plus 14 root 2 is that a cubed. Then we're gonna do the b cubed, which is this thing cubed. And then we plug in here. No, I'll write it like that. I'm gonna write it wrong though. And here's the part where instead of adding these two together like it's there in the formula, we notice that that's a plus b cubed, that's a plus b. Over here in the actual problem, this is our a plus b. We named it a, which I know it's confusing with repeating the letters, but we basically get a cubic like this. Dawn but a stump for when Dawn is stumped. Oh god. Yeah, negotiate parts. You're kind of right. That is, I maybe should have just I don't know, but like a was giving me. I'm just gonna let it be. So I guess what we can do here is we can start combining terms. A cubed is 20 plus 20 is 40. 14 root 2 minus 14 root 2 is 0. These can get grouped inside the same cube root. No, they can't. Yes, they can? Yes, they can. To get 20 plus 14 root 2 times 20 minus 14 root 2. A. Okay. So then a cubed equals 40 plus 3. We have to multiply out that on the inside. 20 times 20 is 400. Minus 14 root 2 squared, which is 196 times 2, which is, I said it was 392 before. 40 minus 3, 40 minus, or 400 minus 392 is 8. The cube root of 8 is 2. Minus 6a, this is just a cubic. A cubed plus 6a minus 40 equals 0. And this is going to be rational roots theorem, unfortunately. I think when there's no squared term, there's some kind of trick for cubics that I can't remember. Like the cubic formula isn't that bad or something like that, but I'm just going to do a rational root theorem. A could be, like the candidates we have to check are plus or minus 1, plus or minus 2, plus or minus the factors of 40. 4, 5, 8, 10, 20. A equals 4 by inspection. Yeah, I wasn't going to go through the pain of checking like every last one of these. I was going to like... I just want to list off like how you would solve this, but kind of like speed through the mental math part of this. Basically what we do is, these are all the factors of 40 with pluses and minuses. We would plug each of these in and see if we get 0 on the left-hand side. And so I would just kind of try and do quick mental math and see if it potentially even could be 0. So like if I plug in 1, I get 1 plus 6 minus 40. Without even trying to give the exact number, that's just never going to be 0. 2 is going to be 8 plus 12 is 20 minus 40. That's not 0. If we do 4, that one's worth checking. I mean, also I'm spoiled and I know that it's right according to Fenbox. Is it? 4 cubed is 64. Sign mistake? Really? We got a drawing and a Rubik's Cube? Okay. Oh my god, integration by parts. Wait. Oh, I made it. I just randomly inserted a minus sign. You're right. Actually, I think if you do a cubed minus 6a equals 40, that's not necessarily easier to solve. Like, factoring doesn't actually help you here. Like, you can't split up into 2 problems based off that, if that's what you mean, integration by parts. Line 7 is now wrong? You're right. There we go. Yeah, now at this point you start doing some mental math to basically check through all of these candidates, but if you take positive 4, you get 64 minus 24 is 40. 40 minus 40 is 0. So A equals 4 is going to be, and I assume by the engineering of the question, the other roots are going to be imaginary or something. So once you get 1, you can probably let that be. How do I show them that? What do you mean? Just calling it boring? Like, how do you show them getting A equals 4? You tell them to stuff it, basically, because solving cubics isn't easy. The only real option is to literally go through that list and try each one. Like, you can show your work of trying each individual root until you get one that works, but it literally is just trial and error, unless you want to do the cubic formula, which is painful, and I would never recommend it in any scenario that's not using a computer to do it for you. But yeah, that's basically the technique there. Hey, Central, 9 times 10 to the 10th? Dang. Been a lot of people before you, apparently. 20 plus 14 root 2. 20 minus 14 root 2. You're at least 2? Yeah. Yeah, 4. Okay. How does Wolfram say to do it? What? Thanks for the meth help. You know, anytime. I'm here to help with meth. I'm gonna come to you with all my pendulum problems. They're doing the perfect cube way, I think. This is so weird. There's been a few things that have been posted in the meantime. Let me look. Because I can't see people's full like Discord usernames right now. You never want to see another pendulum again? I saw this one got posted. Log Inequality also got posted. Oh, this integral one? What was yours? Integration of parts. I'm gonna look at this integral one first. Well, which one is quicker? Yeah, let's do the log first. Greater than or equal to 0. Isn't log of anything greater than or equal to 0? No, no, no. You can have a negative exponent. Hey, Tomas had Hazy over on YouTube. All right, let's we're gonna do that log one. I think we're gonna translate it into exponential form if we can. Oh my god. Every time I get up, what's happening? You already solved it? Oh, okay. I guess that's good news. Oh, Central. I've been dual streaming on YouTube for a hot minute. Only the math. I guess, but I don't remember when did I first start dual streaming the math onto YouTube. I feel like it's been like a year now. Year, hot minute. Oh, thank you. I don't see where you posted the solution, Jaden. Oh, you're sending it. Oh, okay, okay. Do you just, I mean, -2 to 0? I mean, I feel like it's not gonna be how to just work it out, like 4x plus 6 over x. I guess you could do log identities on this too. But I was just like curious what happened if you put it into exponential form. Actually, how did the sign change? Like, I don't know how to go. That's not necessarily an equal sign. It's certainly not an equal sign. How did I not know this? I don't know Central. I guess I don't talk about it all that much. You're gonna lurk? All right. Thanks for lurking, Central. What's up, Quack? There's a couple of questions that are waiting, but ChatGPT is great. True, Zach. Prove that sin x is greater than x minus x cubed over 6? Oh, okay. That seems like a Taylor series thing. I don't know exactly how you would prove that, though. I can try to think more about it when I get to it. For me, I can see the minus sign. Is that like over a domain, Quack? Because that's certainly not true for every x. I don't think. Oh, it's like finding what values of x that's true for. It's something that Quack is putting it in the YouTube chat. X greater than 0? Apparently. I know, I've got to do the question on the board. I've got to do the question that Interview by Parts posted, and then I can look at Quacks. But that's what Quack wrote over in the YouTube chat. What does it mean for log base 1/5 to be greater than 0 or equal to 0? It's positive. We're interested where it's positive, which can only happen that doesn't make sense to me, Jaden. I'm gonna be honest. I want to find a more straightforward way of doing this. Okay, so this my first instinct here, like I'm not sure what the sign in the middle should be. It's kind of unclear to me. I think I can find a different way that is more clear. What I'm going to do first is a log base 1/5 is kind of weird. I'm going to use the identity that Zach suggested and say that log base 1/5 is the same as flipping the base and flipping the inside. And I'm going to use log identities now to split this division up into two separate logs. And what I want to do now is add this log over to the other side. Because I can now do 5 to the power of each side. And doing 5 to the power of each side doesn't mess with this inequality. It just stays the same here. So I'm doing 5 to the power of log base 5x is greater than or equal to 5 to the log base 5 4x plus 6. And we get a cancellation. 5 to the log base 5, it basically cancels and the x comes down. So we get x is greater than 4x plus 6. Now I'm going to subtract the x over there and bring the 6 over here to get negative 6 greater than or equal to 3x. Divide each side by 3 to get negative 2 is greater than or equal to x, or x is less than or equal to negative 2. Let's see if that's right. Hey Storm, there's quite a few questions just from people in chat, so I'm working through them. We were just getting to the end of this inequality here, where this thing is greater than or equal to 0. And I think I found a decent way to solve it. And I'm checking my answer. No, I missed the other bound. Oh, right, because logs in general, we can't have log of a negative number. I forgot to account for that. Yeah, Stelly, so I got part of the answer. I forgot to do the other part of this problem. And that's because with logs, we have to also remember... So what I solved like this greater than 0 bit, but every single log, you're not allowed to have log of a negative number. And so we have to figure out, we basically get like a second problem of 4x plus 6 over x. Actually, you can't have log of 0 either. So we also have to worry about where this thing inside is equal to 0 or, well, it's only valid if this thing inside is greater than 0. If it is 0 or if it's negative, that's bad. Log isn't defined for 0 or negative numbers. So we need to make sure we only plug in positive numbers inside here. So we also need to set up this inequality and solve it. And how does that work? This is a weird situation with logs. Or with inequalities, rather. I think what we want to do is I'm going to split this up into two fractions based on the numerator to get 4x over x plus 6 over x greater than 0. we already don't want x to be equal to 0, so we're allowed to cancel these. 4 plus 6 over x greater than 0. I'm going to subtract the 4 over, I guess. 6 over x greater than negative 4. I'm going to flip both sides to get the x up top. That does flip the inequality. Multiply each side by 6 to get x is less than minus 6 over 4, and that simplifies to minus 3 over 2. That doesn't... My inequality goes the wrong way, doesn't it? Or this inequality goes the wrong way. I messed up the flipping here, didn't I? Because the answer that you showed me is that negative 2 should be less than or equal to x should be less than minus 3 over 2. So I messed up on the first stage of the problem. You only flipped... There's other things you can do that can flip an inequality jet, I think. Depending on what you do to each side of the thing. Yeah, Stelly, I know that this is supposed to be x is greater than or equal to negative 2. By work, I got the opposite, though, so I messed up a sign flipping thing somewhere. I'm not sure where I went wrong here. So I was specifically doing it to try to avoid flipping the sign on the left. That could be it, Thunder. I wonder if I tricked myself by doing that, flipping the base and flipping the inside. Storm might have gotten an even better version of the answer here. That gets both parts of the answer in one technique. I'm still reading through it though. I think Storm may have left off the 4 in the 4x plus 6, but we could always fix that. Hey, Tartar, they sure are separating the two logarithms. Really? That was the issue? I didn't think that would change anything. Oh, yeah, sorry, I might have written it too small. My email? Why do you need my email? Can you just send it in the Discord? You know, are you able to just like... tell me like what the technique is or something? It doesn't take into account the negative values of x. Maybe? So I don't know that I do understand it. Oh, unless you're asking that to Thunder. Huh. Territory, yeah, you might be right there. I don't know about that boat. I can't do your inequalities normally. And there's at least 2 other questions that I am waiting on as well that I have to like get through. All right, so this is what Jaden sent. Yeah, Storm said they couldn't see the question quite right, which is fair. Actually, this is the... I was trying to figure out where the x squared came from, but this is like a bigger text version of it. Let me keep reading it. How do we know that this is less than or equal to? That's the part that I don't know about this technically. This is my first instinct, but I don't know how we justify this inequality. It's a rule? If it's greater than 0, so Storm, that's the same thing that I did, but it should be x. I think that inequality is supposed to be flipped. It should be x is greater than or equal to -2 for some reason. Oh, tear with absolute values. That might be the modification to my technique. If the base is between 0 and 1, the inequality changes. Base is not between 0 and 1, the inequality doesn't change. I'm trying to come up with, like, I guess maybe the intuitive justification where, like, if the log of something is greater than 0, what does that mean for the inside? One-fifth to a power greater than or equal to 0. Hmm. Oh, you have to go? Yeah, I'm sorry, Sly, that I couldn't get you a more definitive technique to do this one. It's just it's a really tricky one. So I could try to get back to you on Discord if I get a technique that like makes intuitive sense to me. There's a lot of different ways that you could do this problem, but none of them quite sit right with me. All right, thanks, Vixa, for hanging out too. Because I think I could work it out the way that like, you know, Storm and Jaden and Territar are saying, but I don't know. I'm just trying to like put myself in the shoes of a student here and like think about what's realistic for me to find on a test. And I guess that's what I'm like, that's the technique I'm trying to like search for. All right, integration by parts. Are you still around? Sure, Jaden. I'm not going to solve it, but if you want to like look at it, just and, like probably be impressed at how hard it is. Um. Can we, oh, you're here? Okay. This question makes you upset. That's not multiplied by X, Storm says? Okay. Regardless, Jane, I think I'm gonna like solve it on the board and explain it, but so integration parts, like, are you asking about a specific part of this, or integration by sub with a U sub at a bound? That's pretty terrible. You don't need to know. Okay, yeah, sure. Ah. So given a is a positive constant, use the substitution x equals a sine squared to prove this integral. So a minus x squared dx. They give us that u equals a sine squared x. Okay. Oh, they don't even ask you to follow through with the integral. Oh, they do in the second part, I guess. Okay. Oh, yeah, you're right. Thank you. I kind of hate they have x to the 1/2 times square root x, but yeah. Oh yeah, Thunder, will do. Sorry, yeah, things are a bit too busy to draw right now. You are refunded. Oh, I might need to refund Zach's redeems too. Okay, so du then is 2a sine x cosine x dx. Just making sure that I'm copying the problem down right. All right, and then when we apply the u sub, right here, x is equal to 0, which means u is equal to 0, cosine of 0 is 0. Don't we just get, then if x equals a, isn't that a sine squared a? We just don't know what that is. How do they get pi over 2? You're too stressed? Oh, yeah, that's fair. Does anyone find inverse fun? They can be bowed to me. Oh, they do a second sub. This is in terms of theta. Oh, that's kind of funny. Oh, wait, no, I copied the problem down wrong. Oh my god. Or I copied the sub down wrong. Ugh. It's x equals a sine squared theta. There we go. That's why things weren't looking right. So dx is 2a sine theta cosine theta. D theta. There's some integrals that are just like painful, like partial fractions, but the clever ones are fun. Yeah, but like I hate the types of problems that you do normally, to be honest. Just different types of math that we enjoy, I guess. Okay, but so here if x equals 0, theta is also 0. I mean, theta can be 0, pi, 2 pi. I think we're just solving it in the first quadrant, though. Right now, as long as we're consistent with our values, it should all be the same. Implies theta equals 0. And if we have x equals a equals a sine squared theta, we're just taking the first solution that we can get, which is sine squared theta equals 1, which is pi over 2. Okay. So you change the bounds. If you need to explain that more, then let me know, but I'm assuming that the more difficult part is manipulating the inside here. So dx is equal to 2a sine theta cosine theta. Sine theta cosine theta. Root a minus, we said x is a sine squared theta. Oh, okay. D theta. I see where this is going to go now. Math in India is too insane. Bulgarian math? Oh, yeah. Yeah, we're going to get a lot of cancellations here. I'm a little concerned about that cosine theta. I think I see where it's going to go away, though, hopefully. The 2a can come out front. Sine theta, cosine theta. This a can get factored out, and it'll get its own square root on the way out. 1 minus sine squared theta, d theta. Really? Oh, sine squared 2 theta. But what about the a? How is it a squared? Just didn't realize it was a constant. Oh, that'll do it. I'm a little concerned that this a is square rooted. It's not. I don't see how you possibly get this to be not squared, because it's supposed to be a squared on the outside, but I'm getting a to the 3 over 2. So I don't know what to think about that. But maybe let's just keep it going. 1 minus sine squared theta is cosine squared theta. The square root of cosine squared is just cosine. So you get sine theta cosine squared theta d theta. This This is not quite right. What? I miss a square root A? Oh, I did. I forgot that's a 1/2. Okay, good call. See, that's why I don't like mixing the 1/2 notation and the radical notation. This entire thing is square rooted. No. Wait. I'm sorry. I'm talking crazy. I forgot the x to the 1/2 entirely. That's the issue. Oh god, just erase this entire thing. Okay. I was just focusing on the dx and then that square root. I just left off the x to the 1/2 entirely. That's my issue. Okay. X to the 1/2, 0 to pi over 2. X is a sine squared theta, so we get root a sine squared theta. A minus a sine squared theta. And then dx is 2a sine theta cosine theta. This should be right now. That's just, that root a can come out front. That 2a can come out front. That root a can get factored as square root and come out front. 0 to pi over 2. Sine squared, square root of sine squared is just sine. 1 minus sine squared is cosine squared. Square root of cosine squared is cosine. We just get sine theta cosine theta. There we go. This on the outside simplifies to 2a squared. 0 to pi over 2. Then there's a half angle identity, which is sine 2 theta equals 2 sine theta cosine theta, I believe. And that's good. Okay, good. So if we divide the 2 over here, we have 2 sets of this identity. So it's going to be 1/4 sine squared 2 theta d theta. The 1/4 goes out front. So you get 1/2 a squared 0 to pi over 2. Sine squared 2 theta. Jeez. Performance is wild. Two marks for altering bounds. Yeah, I mean, this shouldn't have taken me as long as it did, but just like, it's kind of finicky with everything that's happening, but they do want you to actually integrate this for part B, so we can do that. Now my next question is, wouldn't you rather have, don't you want to undo part of this? Like, you can't integrate sine squared directly, can you? What I want to do is, oh no, you need to use a different half angle, I guess. Well, yeah, how do you do this? You don't need to integrate it? What do you mean? Well, no, part B says to actually integrate it. Bode. I guess if it slows down, I'll look at it, but I have this and the potential one from Quack if Quack is still around. I mean, that's something like the area of a circle. Okay, yeah, sorry Quack, you're up next after this one. I'm still trying to figure it out though. We can use that identity right there. I think that's what I was looking for. You don't need to do this. Oh, okay. I guess in that case, let's look at Quacks. So Quack was saying, prove that sine of x is greater than x minus x cubed over 6, or x is greater than 0. And x minus x cubed over 6 is the Taylor series. But just confirm, I want to look at this in Desmos. Oh. Oh wait, no, greater than, yeah. I mean, how do you prove that's an under approximation though, Jaden? That's, to me, that's kind of like the key thing here. Take the derivative? How will that help? Oops, didn't mean to do that. What would we do with the derivative? Like, I don't think the inequality would survive being derived. Hmm. Well, how do we know that's true though, Jaden? If we take the derivative of each side, I think you have a separate thing to also prove then. Taylor series or Maclaurin. It's depending on what you're centering around. Sine x minus the stuff is greater than 0. Is there anything you can do with like the remainder? Like maybe what syntax error is saying with like showing it's positive? I'm interpreting it at least. Oh, take the derivative of that. Huh. Jaden, that seems clever, but I don't know if that actually works. So why can't you just go for a fourth term also? Or like, that is clever, but I don't know, it makes me uncomfortable because why, like, the three terms, it feels kind of like arbitrary. Syntax error, like, so sine of x minus this, like, you know, second order approximation, how would the derivative of that help us? X minus x cubed over 6. All right, enrichment parts. Thanks for hanging out. Hardlocked 100th? 3 a.m. here? Oh, geez. Yeah, get some sleep, Jaden. Corrupt. Work on the problem that I just put up on the screen. Like, you don't need sleep. Because this is definitely, it is just like the Taylor series, but like, how do we... I feel like... I don't know, I have a hard time agreeing that some of the stuff is like an actual proof. If we did do that thing with letting f of x equals sine of x minus x plus x cubed over 6... I mean, yeah, the real answer is just graph it, Jaden, but I wouldn't call it trivial. Hey, Sidikant, Mishra. Yeah, like, people are talking about derivatives, but like, I feel like using derivatives to prove an inequality is kind of dangerous. The problem's up above me, Bladwy. There's a lot of back and forth about people just suggesting solutions, but none of them feel like proofs to me so far. Maybe that's because I'm not familiar enough with inequalities and integrating and deriving with them, but I feel like there's no way that... Well, I don't know, maybe it is. It looks like just for a fun question, Jaden. This one is an actual question from Quack. I prioritize like questions people are actually like asking for help with. But yeah, Quack. I do like the idea of what people are suggesting, which is, well, yeah, that's what I'm saying, Jaden. The point of the stream is like homework help questions, not just people giving me questions for fun. So, I mean, if there's extra time, I'll look at questions for fun if I feel like it, but... I'm going to prioritize like actual like help questions people have. So like, I like the idea of naming a function like that, which is the actual function minus the estimation. But the thing is, like, taking the derivative of this, or even doing the second derivative, I don't necessarily see how that helps. The next term of the sine series is negative. Well, the next term is positive, then the next one after that is negative. Yeah, that'd be a way to do it corrupt. I'm not sure. I'm thinking. Prime x is always positive. F of 0 is positive or non-negative. Okay. That seems... Is f prime x always positive? I need to actually do that out. X squared over 2. So I'm potentially worried about small x's here. Like from 0 to 1. But I do like that if we can show that this thing is positive, that the derivative is always positive, and that the initial function is 0 or a positive number, then the difference is always positive, and that kind of proves our inequality. So yeah, if we start at 0 and we're always increasing, I think that's our job done. How factorial scales? I got a feeling I probably won't be able to do your questions from you, Jade. I'm sorry, but like, I think you're just like built different. And I'm just not the type of math that it seems like you're doing. Cosine x between -1 and 1, so cosine x minus 1. X squared over 2 minus 2 is always greater than 0. Oh, no, I don't think it is. Let's hit a cunt. For a small x, I don't think that's true. So it's decreasing at that point. Can we notice? So I guess VOD, that would be nice, I guess, kind of. If we have an inequality and we integrate each side, I guess that preserves inequalities. Like, we don't have to worry about that. Renga, the problem is like up above the cam there. There's been a lot of suggestions back and forth that it's kind of hard to like follow just one line of logic here. I think we're kind of converging on something with letting f of x, or naming a function f of x that equals the difference of these two things and trying to prove it's greater than 0. It's like I'm following like syntax and VOD, who are working on like taking the derivative and showing the derivative is always positive for x greater than 0, and that we start from 0. So we're always the difference is always positive. But we have to show it's always increasing first. And VOD is saying to do that with the second derivative. Oh, and so yeah, VOD, you're saying just show that the second derivative is always increasing, which implies the first derivative is always increasing, which implies that the original function is always increasing. Okay, that makes sense, I guess. I think I follow that now. So if we look at the second derivative, cosine x derives to minus sine. That derives to just x, and we're interested where this thing is greater than 0. And I think that's like, so now this is where you said it's trivially greater than 0 VOD, which I guess I don't know how hardcore we need to be about this. But I do think it's right that x is greater than sine of x for x greater than 0. And so if you know the second derivative is always increasing, or sorry, if you know the second derivative is always positive, the first derivative is always increasing, and we can show that the first derivative starts hopefully from 0, or a positive number. 1 minus 1 plus 0 over 2, which is 0. So the first derivative is always, it starts at 0 and it's always increasing, so it's always positive, which means this difference is always positive. I think that's our proof. Blunder, x less than sine x, really? No, it's not. Yeah, I mean, I was thinking about like this right part of the graph over here, but like I'm pretty sure it follows for, or it keeps on for small x's. Like it doesn't cross over. It's all good, Jaden. So yeah, Quack, I don't know if you're still here. This has been kind of a mess of an explanation, but I think this is the best shot, or this is the best explanation that I can come up with. You are? Okay. So I don't know how much you've been following this. Do you want me to like try and explain it from the ground up, or you get it? Okay. Or so next I might have a pretty neat way to go about this. Okay, so, sounds good, Quack. I think we're going to keep discussing it a little bit, but you don't have to stick around if you don't want. Yes, next I'm happy to hear. Oh wait, using the mean value theorem. The absolute value of sine of x is less than the absolute value of x. You can use the mean value theorem. So the mean value theorem just copy down what Zone is saying. The mean value theorem says that exists a C, f prime C, such that it's equal to f of b minus f of a for b minus a. And like, would b be x and a be 0 here, or like, Like something like that? I don't really know if I'm doing that right though. Take the absolute value of both sides. Okay. I don't know if I'm supposed to sub f prime c for something, but I'll just leave it like that. Yeah, I don't know what you do with this, I guess. Oh, f prime c is equal to cosine of c. Oh, I was looking at my like theory f prime that I wrote up there, but yeah, if we're just doing it with f of x equals, yeah, okay. Cosine of c. And then the idea here is that at least for 0, is less than x is less than pi over 2, we could just say that 0 is less than this thing? No, I think I'm messing that up. We don't have to be a 1. Because if these two things are equal and cosine is at most 1, and then from this we would get that x is greater than sine of x. And I think this would build up the layers from this second derivative argument. Or no, I guess you can even just go directly from this to like, we have x minus a positive number. Can you hear the letter limit? Yeah. Oh wait, you know what? I'm drawing the wrong conclusion here. Z can be as a non-differentiable functions. We're using the MVT just on sine of x, Jaden. I'm kind of doing a bad job with mixing my notation. This isn't the same f here and here. Here the f is just sine of x. And I'm writing in a confusing way because I didn't know where the argument was going. Oh, did I just write the wrong sign there? The absolute value of cosine c is less than 1. I think I'm supposed to flip this. I'm thinking of this inequality wrong. And I think since we've proven that, if you take this x and subtract off a number from it, this inequality still holds. Because x is less than. And that's the idea. And we're only really concerned with where both these are positive anyway, because, or like where both these are, yeah, we're only concerned where both these are positive. And we're only really concerned with small values of x. For big values of x, it's like quote unquote trivial. Scrimp. I was thinking about that, but it didn't seem all that helpful, to be honest. Or I didn't like how to use it, I guess. Okay, yeah, and Zone, thanks for like spelling that out a bit more. In the form. My inequality is not correct? Oh, I thought cosine. It's because I'm writing in the wrong order. But doesn't that give us an inequality going the wrong way? No, shoot. I had it right the first. Oh my god, yeah. Ugh. Like that. Because we want x to be greater than sine of x. There we go. But then how do you just... So then my last step there isn't right. But you could still follow this argument with the derivatives up, starting from that fact. Okay, I know, there's just like too much happening for me to follow everyone's like Oscar's problem, to be honest. I'm a little bit like overwhelmed with the amount of like suggestions, which I appreciate. I just have to learn to like manage it for myself, I guess. um I'm looking at what Jaden posted. I have about 0% confidence I can actually do this, but let's at least try. This isn't the problem here. I need to bring it up still. Wait, this is the problem. Well, one of them. Yeah, I have no clue. 4 to 5 minutes? Wow. I'm thinking about this almost like a... It almost feels like a weird vector type problem. But it's not, it's more like an imaginary number, but with root 2 instead of root -1. Yes, Hidakant. So, I mean, I don't really know how to do this type of question. Kind of. Get rid of that, 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 get rid of that. I have so many tabs open, dude. What the hell? What was the other question? Yeah, these are from the same person. I don't think I can do either of these, but Jaden's asking for help, so I wanted to at least give a look at it and see if I can possibly figure out how to do it, but I don't think either of these are going to be possible for me. Check question 10 from this link. You seem to have a lot of faith in me after I can't do either of your other two questions, but I guess let's see. Two 20 minutes of thought. Yeah, Dr. Meanfield, that's usually if I see a year in a problem, I think like, oh, it's a competition problem. I kind of don't want to do it. Was there a 20? Oh yeah, in this one there's 2024. I think this is for like is this like a standardized test or is it a competition, Jaden? Like, does this test like determine like what kind of universities? Oh, okay. Entrance exam in India. Okay. That's kind of crazy. This is way harder than like I haven't. I haven't, a bachelor's in math, and I didn't have to do questions like this to get into the top unis in India. Oh, okay. Jeez. A, B, C, D are between 0 and... Wait, no, they're exactly 0 or 1. Okay. And the determinant of A is -1 or 1. Same way remembering 10,000 digits of pi is math. It's really tough because they're trying to eliminate candidates with every question. That makes sense. And I'm sorry if I'm pronouncing your name wrong, Sidikant, but like when it says it's just meant to like weed students out and just get you a small group of students, regardless of how you do it. The number of elements in S. So it's all such matrices such that these entries here are 0 or 1, and the determinant comes out to be -1 or +1. I mean, that one actually feels like I could maybe figure this out with enough trial and error. I don't know how you do this quickly, but... if you have 5 variables with 2 options each, is that 2 to the 5th possibilities? I guess it would be 32 possible matrices. So that's probably a little bit more than you'd want to brute force. You can maybe eliminate some categories of these. Like if C is 0, you might get some kind of pattern regardless of what the other ones are. They kept extracurricular activities and all the rich kids would go to college. Wow. They keep the... Huh. That's kind of an interesting, like, perspective, Jaden. Because, like, I feel like, a lot of people make the argument that, like, the rich kids have more resources to study for this, so they'll still have an advantage. But I don't know, to be honest. Oh yeah, so I dual stream to Twitch and YouTube Sidicon, so most of the discussion is happening over in the Twitch chat. And I know it's kind of weird, like I just play the Twitch chat like up there, but it's kind of hard to follow, obviously. Oh, do I not have my link set up? Oh no, it does, okay. But yeah, so if you want to even have like your own like tab, just have like that chat open. Sort find determinant in terms of A, B, C, D, and E, then just make cases. You make a 5-variable equation with just the values. Tuition year is free if you can't afford it. If you can't, it's 10K. Switch to Twitch? Okay. It's up to you. Yeah, I mean, I guess if we do get the equation for this determinant, we can probably do something. Out of the 3 that you've sent, this one feels like the most achievable for me, I guess. C, D, and E are all 0. Okay, so that's one category we can throw out, then scrimp. It's good to know. Put in values had like 30 equations. Okay. I mean, hopefully we can figure out a way to narrow it down so it's not quite as big as 30. Okay, so 0, 1, C, I think that was a 1, AD, 1, BC. No, that's E. Why are the letters used in that? Oh, I guess because they're going on the columns. Okay. The answer is 16 apparently. Oh yeah, it is 16 apparently. Hopefully we can figure it out. So yeah, the determinant of A. If I expand, I don't know, I'll just expand along this column because they're there's no variables for the coefficients. 1C, B, E. C, A, D. Right? I'm getting my signs right. The first one is 0, so we don't care about that one. 1C, B, E. Okay, I think this is right. Plus D minus AC. Okay. So that's the determinant in terms of A, B, C, D, and E. Give me some D. Okay, Jaden. A, B, C, D, E. Oops. Are 0 or 1. And I guess the determinant of A. Is -1 or +1. Okay, so yeah, this feels pretty open-ended. I was hoping there'd be some more obvious thing we could do here. Like, I was thinking that C seems special, but it doesn't seem that special on this format, at least. Like, we could factor the C out from the terms that have it, but I don't think that does all that much. Eleven, 6, 7, 8 are nice. Hey, Mixie over on YouTube. Yeah, sure, if you want to post the question. Please do. And I have a Discord where you can do that as well, if it's easier to put a screenshot. I'll do a table. Really? Like, I guess like this? That's a lot of possibilities, though. Like, we could do this and just like count in binary up to 32, I guess. So like, just from that row, we know that all zeros is out. That's what you did, Jaden? Okay, yeah, so I think there's only 32 possible matrices, I guess, but I thought it was, I don't know why it's not. Oh wait, 2 to the 5th is 32. Oh my god. Just do A, B, and C? Really? Oh, I guess let's use hit a comp. Thanks for the follow. Does that somehow boil down our possibilities mode? If we look only at A, B, and C? Like, I assume to get that part of the equation? Just hardware from this point. Oh, okay. I think that this might be something that can save some work though, because this I'm just doing this out of my interest now. This is only 8 possibilities. I don't know. It's still kind of... It's still kind of messy. You do only get... yeah, I don't know how you exactly use that. Some SMRT, smart stuff to make it less tedious. Okay. Like SMRT, I haven't heard of that. Is that like an algorithm? But no, just smart. Yeah, you could just do it getting all 32 possibilities, I guess. You have your answer book? Okay. So yeah, Mixie, if you do still have your question about simultaneous equations, please do let me know. I don't see it right now, but feel free to speak up in chat if you do post it. But yeah, sorry, Jaden, I can't like help you with your questions, but it's just not at all the type of math that I know how to do. Yeah, Mixie, I haven't seen anything from them yet, and I don't think there's any other questions in queue, so we can look at yours, Bode. Sorry, I think I'm going to be doing that for another like 25 minutes or so, and then I am going to switch over to Phasmophobia. But that's still some time to look at this. We have a concyclic quadrilateral PQRS. I forget what concyclic means. I feel like I've seen it before. Rupik, Goheen. Oh, I see. I believe that was you who posted the, or I think I saw you join the Discord. You can put it in the math discussion channel or the math homework help channel. And if you can't find it, just let me know and I'll at you. So it'll like give you a ping there. And then once you do post it, just like type in chat that you've done it, so I make sure to go and check it. It's in a circle? Okay. So quadrilateral, we have one right angle from Q. H and K are perpendicular. Oh, geez. I've got to draw this. I can't follow it. Send the question in Discord. Sounds good, Rupik. I'm gonna look at this one first, and then I'll get to yours. H and K. Okay, so let me just draw PQRS first inside of a circle. It's basically PRS is our right angle. PSR is our right angle. Okay, yeah, so I'm going to start with the right angle. Then I'll specifically draw this, obviously not at a right angle. P, Q, R, S. H and K are perpendicular foot from Q to sides P, R, R, S. So from Q perpendicular to PR. So we have, that point is H. And probably something like that is K. Prove that HK bisects segment SQ. HK bisects SQ. That's probably misleading to connect those two. Yeah, if you post a drawing, I'm going to look at it because I feel like I'm maybe not drawing this in the most instructive way possible or the most like helpful way. Okay. So our right angle's down there. Wow. And we want to prove HK bisects SQ. So this green solid line bisects the red solid line. Yeah, I don't know how you even start with this. Should we, QH is perpendicular to PR and QK is perpendicular to PS. I believe. And VOD is posting this in the Math Homework Help like forum. If you want to like pull up your own copies. PSR is right. Oh, okay, okay. Simpson line? I never heard of that. And Rubik, I don't see your question yet. I am keeping an eye out for it. I'll at you in case it helps. Okay. PSR is a right angle. KQ go to PS. Oh yeah, I think I can do that, Rubik. Once I'm done with this geometry one. Yeah, I think Build does do competition math, which is why I normally don't do Build's problems. But apparently Build is taking it easy on me for this one, so... Given a triangle ABC and a point P on its circumcircle, the closest 3 points to P Where is P? Oh, this is P. Okay. All right. See ya, Jaden. It's a P on lines A, B. Huh. That's what? What a crazy theorem. How do you figure this out? There's a proof right down there. I don't want to actually know though. Take Q as P in the drawing. So our triangle then is PRS. Draw the height from Q to RS. So yeah, the closest point would be somewhere, wait, to RS. Closest point then would be somewhere over here. And I guess for RP, it'd also be in the same area, but a little bit lower. Wait, but then theorem that HK, they're collinear? Wait, what was the, prove that HK bisects SQ. HK bisects SQ. I don't know how that helps. Okay. From Q to RS. Oh wait, actually, I should just do this in Paint with the drawing that you gave me. Okay, so something like that. Maybe I'm not drawing it right, but it's supposed to be HK in right angles there, and there. QKS? QK. Oh, okay, sure. Oh, well, thank you, Mangoes. Something about Q, S, and K. Q, S and K, well, they form a right triangle. And the new point, there's another right triangle. USK. Calling the new point A. USK. The new point. Well, I guess there's a shared hypotenuse with triangles UKS in triangle AQS. Right angles for sided for, oh, there are, oh, it's a rectangle. AQKS. Okay. And AH and K are collinear. So AK is a diagonal of the rectangle? And QS, okay, yeah. And they bisect each other? Because it's a rectangle. Okay. Wow. Yeah, for me, that's not even slightly easy. I do that on my own. I don't, yeah. I don't know where to, I wouldn't be able to do that on my own, I guess. That is an interesting problem, I guess. I just don't know the tricks with those. I've been keeping Rupic waiting for a while, so I want to look at Rupics, and I think I'm gonna switch over to Phasmophobia. I can look at it maybe like Offstream or something, but I feel a little bad keeping Rupic waiting. So yeah, Rupic, if you're not still here, I'll DM you on, or I'll like get back to you on Discord. But I think this double integral won't be too bad to just integrate with x first. X over x squared plus y squared dx dy. Okay. Goodbye, you gotta sleep. All right, get some sleep, Bode. Thanks for the problem. Sorry that I can't engage with it better, but yeah. So, I definitely want to integrate x here first because we can do a u sub with u equals x squared plus y squared, treating y as a constant. I hope this is right. I haven't done a double integral in a while, but I think you can treat just y as a constant for the sake of this. So you get 1/2 times 1 over, well, ooh, that doesn't seem right. Yeah, how do you deal with that? Shoot, you know, my double integrals are a little bit too rusty apparently. Let me look back at how that works. Because I do love doing double integrals. I just haven't done them in a couple of months at least. So if we looked at like one of those last two. Oh wait, so you can just do a U sub like this, apparently. Consider y as a constant inverse. Okay. Yeah, I guess it just like felt wrong to me because I didn't know. Okay. I'm glad I'm remembering it right, I guess, but I'm definitely going to rewrite in Wolfram Alpha after this. If we integrate this, we get 1/2 ln. Then u was x squared plus y squared dy. And now we need to integrate. Oh god, what is that? Do you integrate y first? Because that doesn't seem easy to integrate, ln of y squared. Thanks for confirming that, by the way, Sidicon. We could integrate. Yeah, I don't know how you do that. So what if we instead tried it with y first? You'd be arctan. Shoot, how does that formula work? Integral. I don't know how you Google this type of integral. Oh, here it is. I just want the formula. Okay, it's 1 over a arctan x over a. Okay, so this x just stays in front, and then 1 over x squared plus y squared integrates in terms of y to 1 over x arctan y over x dx. I think that's what we get. Let me look at it though. Yeah. Go polar on it? Oh, polar is probably a good idea too, but obviously available answers. I think it should be possible like this too, but polar is probably not a bad idea. Actually, how do you integrate arctan though? Oh, this is arctan in terms of x. Maybe you do need polar. Because I don't know how you integrate that either. Okay, well, let's see what it's like in polar. So attempt number 1, attempt number 2, attempt number 3. X is r cosine theta. X squared plus y squared is r squared. And the integrating factor you get from polar is r dr d theta. I don't think integrating factor is the right word, but oh, fembox. Yeah, the r squareds cancel. Cosine theta dr d theta. Integrating with respect to r first, you get r cos. Oops, just one integral. R cosine theta d theta, and cosine integrates to positive sine. And now we do have to unsub, which means r is root x squared plus y squared, sine, and theta is arctan y over x. And we can simplify that. Arctan is opposite over adjacent, and so sine of this theta is opposite over hypotenuse. X squared plus y squared times opposite y over hypotenuse. That's not good. That's not an available answer at all. It's just y? Oh, it might have been possible to proceed from my second attempt. These are a lot more complicated than the answers I got. The heck? Do any of them simplify? Like, are they not given in simplest form? Partial differentiate the options? True. Use Wolfram to find the answer. That's Dr. Wolfram. Do you really integrate the constant? That's weird. 1/2 y. Oh God. The next issue is seeing, well, whether Wolfram's answer actually matches with any of these. I don't think it does. What? We have an arctan y over x here. Unless there's some weird identities that are happening, there's no arctan y over x in any of these. Same with the ln. Yeah, Rupek. This is weird. I don't think any of these are the same as what Wolfram gets. A square root of an arctan? Like, what the heck? Where does that even come from? I don't know why my polar thing was wrong either. It clearly is wrong, like... Oh, God. Integration by parts? For like the first thing I tried, like you think it's possible to integrate ln x squared plus y squared dy? hang up your math hat and play video game. That's what I'm about to do after this problem. I'm gonna let Wolfram Alpha figure out. Can you do the integral? Let's just give it a simpler version of it. 1 plus x squared dx, Wolfram. Oh. Integration by parts. Okay. Let's try it, Sidicont. Arctan. I thought my thing is right, but either way, if we're gonna try it from this, it might be possible to integrate this by parts, or it seems to be possible according to Wolfram. So I'm going to take u equal to the complicated thing. dv equal to dx. du is 1 over x squared plus y squared. We care about y, so times 2y dy. Oh, that should be a y there. v equals y. So uv minus v du, y ln x squared plus y squared minus integral v du 2y squared over x squared plus y squared dy. You can maybe simplify that. Y ln x squared plus y squared. Because we could do a fancy plus x squared minus x squared. X squared plus y squared dy. X squared plus y squared minus 2 integral. We split it up into fraction like that, and then a minus x squared over that. So you get 1 minus x squared over x squared plus y squared dy. Y ln x squared plus y squared minus 2y plus 2 times whatever that integrates to. Which is going to be another arctan. And I'm going to... That x squared stays, I'm going to say, times 1 over x squared arctan y over x. That's what I think it's supposed to be. Does that even remotely match with any of the answers now, though? Yeah, critical. It's Calc 3. Looks good. Okay, thank you for solving along, Sidicont. If you do post a solution, I'll look. There's no addition in any of these answers or subtraction. I don't get where this answer comes from. Or where like the options for the answers come from. Unless they're doing some weird identity stuff. The why where critical. Oh, when I did that first U sub, when you do a double, when you have a double integral, you first integrate in terms of one variable and pretend the other one is a constant. So in that one, I pretend the y squared is just a constant. So even though it's a variable, you're allowed to just pretend like it's a 1 or, whatever number you want for the sake of doing an integral like this. Yeah, I don't know why there's no plus c's at either fembox. Did they do like a change of variables on the answer here somehow? That's the only thing I can think of that maybe, but I really don't know. Like the thing that stumps me the most about this is where that 1/2 on the arctan, I guess on the y, not on the arctan, but like where that negative 1/2 exponent comes from. But if any of these answers are correct, there's some crazy change of variables here. But yeah, Rupik, I can't get any of these options either, as far as I can tell. I'm going to refund Zach's points because he redeemed things like 2 hours ago and I never did them. Sorry, Zach, if you're listening. So yeah, Rubik, I'm sorry. I think I made a progress that I can with this. I don't know like what else that I can do with it. Option C because it's too different. Honestly, Jed, that's not like a bad way to. I've absolutely gotten the right answer on tests just by like looking at the psychology of making the wrong answers. Yeah, Rupik, thanks for asking. Phone a friend isn't working yet. I think it's going to be time to switch over to Phasmophobia, though. It's about the time where I wanted to switch over. I'm going to take a quick like bathroom break before that, but question is bogus. Yeah, I mean, it doesn't match what I got, so the question must be wrong. I know anyone else is on is doing math, so I don't have anyone to recommend you all over. But I think I'm going to close up shop there for math for the day. Yeah, Alejandro's going. I think Alejandro's even sleeping right now, like his stream is on, but he's not doing anything at the moment either. 5 more minutes. So I'm about to cut off the YouTube stream. If you do get anything, if you hopped in the Discord, Rupik posted it in the math discussion channel. Feel free to put it there if you do get anything. But I'm getting a little bit done with math right now. Thing goes with at hard. I think Carlex is already streaming too, which is great to see. Hard locked. And friends, because I assume Jed is going to be in here. Switch to Spanish class. I thought I saw you live. You're in. Oh no. Do you still want to play? If not, it's all good, but. Are we playing? Okay, yes? Okay, good. Okay, just wanted to make sure, because I'm still down to play regardless, but if you didn't want to, I'd understand. Scared of the dark? Okay. But yeah, I'm kind of YouTube stream off here, so Rupik and Sidicon and Anos is here on YouTube. I appreciate you all. I'll be back on YouTube on Saturday, and I'm always available via Discord, so if anything comes up, please let me know, but see you YouTube.